Imagine holding a human brain in your hands, a labyrinth of neurons firing in patterns, weaving meaning from matter. Now imagine zooming out, far beyond the Earth, past the stars, past the galaxies, until the entire universe comes into view. Strangely, it looks familiar. The galaxies are not spread randomly but strung along vast filaments, clustered like neural pathways. The universe, on its largest scales, looks like a brain. This is the cosmic web, the vast and intricate network of matter that stretches across the observable universe. It is the largest structure in existence, and yet it shares a surprising resemblance to something small enough to fit inside your skull. The comparison between neurons and galaxies is not just poetic. It is a statistical and structural similarity that scientists are only beginning to understand. The story of the cosmic web begins with a question: how is the universe arranged? For centuries, astronomers assumed the stars were scattered randomly, like grains of sand thrown into the night sky. But as telescopes grew more powerful, and as we began to measure the distances to galaxies, a hidden pattern began to emerge. In the mid-20th century, astronomers created the first three-dimensional maps of galaxy positions. They expected to see galaxies sprinkled evenly across space. Instead, they found vast chains of galaxies forming walls, separated by enormous empty regions called voids. It was as if the universe itself had formed a sponge-like structure, with dense regions of matter surrounding great hollows. These discoveries challenged the very idea of cosmic uniformity. Later, with the Sloan Digital Sky Survey and other deep mapping projects, the cosmic web came into focus. Galaxies were shown to align along enormous filaments that stretch hundreds of millions of light-years. These filaments intersect at nodes, clusters of galaxies containing thousands or even tens of thousands of individual galaxies bound together by gravity. Between these filaments lie the voids, vast, dark regions that can span 500 million light-years with almost nothing inside them. What sculpts such a structure? The answer lies in gravity and in the mysterious substance called dark matter. Dark matter does not emit light, and we cannot see it directly, but its presence dominates the universe. It provides the invisible scaffolding upon which galaxies and stars are built. In the early universe, tiny fluctuations in density allowed dark matter to clump together. Over billions of years, these clumps grew, pulled by gravity into strands and filaments. Ordinary matter, gas, and dust followed, settling into the valleys carved out by dark matter. In time, galaxies formed along these filaments like pearls on a cosmic string. When simulations of the universe are run on supercomputers using the laws of physics and large amounts of dark matter, the result is astonishing. A web emerges, nearly identical to what astronomers observe. These simulations confirm that the cosmic web is not random, but the inevitable outcome of simple physical laws acting over immense timescales. Now, here is where the comparison to the brain becomes striking. The human brain contains roughly 86 billion neurons, connected by trillions of synapses. The cosmic web contains perhaps 200 billion galaxies, connected through filaments of dark matter and gas. When images of neural networks are placed side by side with simulations of the cosmic web, the resemblance is eerie. Branching, clustered structures, with hubs and nodes linked by filaments. Scientists have gone further than visual similarity. In 2020, a team of researchers compared the statistical properties of neural networks with those of the cosmic web. They found that while the scales differ by 27 orders of magnitude, the brain is measured in micrometers, the universe in megaparsecs, the patterns of connectivity are remarkably similar. Both systems balance efficiency and robustness. Both distribute information, or matter, in a way that avoids centralization yet maintains order. But does this mean the universe is literally like a brain? The safe answer is no. Galaxies are not neurons, and dark matter filaments are not synapses. The universe does not think, at least not in any way we understand. The similarity is structural, not functional. Yet this resemblance invites us to ask profound questions. Why do such similar patterns emerge in such different systems? Is there a universal law of complexity that shapes matter, from the microscopic to the cosmic? Some physicists suggest that networks follow similar optimization rules, regardless of scale. When energy or matter must flow efficiently through a system, whether electrical signals through neurons or gravitational flows through galaxies, certain patterns repeat. Nature seems to prefer webs, networks, and branching structures. We see them in river deltas, in lightning bolts, in fungal mycelium, in the veins of leaves, and even in the circuitry of our own technology. The universe may be diverse in its details, but the patterns echo again and again. The cosmic web also teaches us about the fate of the universe. Today, the filaments are still forming, as gravity pulls matter together. But dark energy, the mysterious force accelerating the expansion of the universe, will gradually pull the web apart. Over trillions of years, the filaments will stretch and thin. Galaxies will drift farther from one another until their light can no longer bridge the growing voids. Eventually, the cosmic web will dissolve, leaving only isolated islands of matter adrift in an ever-darkening cosmos. The brain, too, changes with time. Neurons die, connections weaken, networks reorganize. The similarity extends even into the arc of growth and decline. Both brain and universe are temporary networks, structured by flows of energy, bound by laws of efficiency and decay. There is also a philosophical dimension to this comparison. The brain is the seat of consciousness, the structure through which the universe becomes aware of itself. And the cosmic web is the stage upon which all galaxies, stars, and planets exist. In a sense, the brain is a miniature echo of the universe, and the universe is the vast canvas upon which brains emerge. The microcosm and the macrocosm reflect one another, not because they are the same, but because the same laws sculpt them both. When we look at the cosmic web, we are not just seeing the distribution of galaxies. We are seeing the fingerprint of physics on the largest possible scale. And when we compare it to the brain, we glimpse a strange unity in nature. Complexity emerges through networks. Order emerges through connection. And beauty emerges through pattern. So, does the universe look like a brain? Visually, yes. Structurally, yes. Functionally, no. Or at least not in a way we can prove. But the comparison reminds us of something important. We are part of this web. Our neurons are made of atoms forged in stars, which are themselves clustered in galaxies, strung along filaments, stretching into the vastness of space. The brain, contemplating the universe, is the universe contemplating itself. And as we map the cosmic web in greater detail, with new telescopes and simulations, we continue to trace the outlines of this vast network. Each new map reveals not only the structure of the cosmos, but also the patterns that link us to it. The resemblance to the brain is more than coincidence. It is a reminder that the same physics shapes all things, from the spark of a neuron to the sweep of a galaxy. In the end, perhaps the universe does not think like a brain, but perhaps brains think like the universe. And that thought, in itself, connects us to the web of existence, from the smallest scales to the largest, bound together in patterns that stretch across time and space. When we talk about the cosmic web, we are talking about scales so vast that ordinary language begins to falter. A single filament can stretch for hundreds of millions of light years. Entire superclusters of galaxies ride upon these filaments like beads on a string. To truly grasp this immensity, we need to explore some of the grandest structures we know: giant walls, superclusters, and attractors that bend the paths of galaxies themselves. Take the Sloan Great Wall, discovered in 2003. It is one of the largest single structures in the observable universe, stretching more than 1.4 billion light-years from end to end. That is about 1/10 the diameter of the entire observable universe. Inside it are hundreds of thousands of galaxies, each with billions of stars. If you could fly across the Sloan Great Wall at the speed of light, it would still take you over 1 billion years to reach the other side. And yet, this wall is not isolated. It is one strand in the greater web, one stitch in the cosmic fabric. Our own Milky Way belongs to a supercluster called Laniakea, a Hawaiian word meaning immeasurable heaven. This name is fitting because Laniakea contains about 100,000 galaxies spread across 500 million light-years. The Milky Way, with all its stars and planets, is just one minor spiral within this colossal city of galaxies. At the heart of Laniakea lies the Great Attractor, a mysterious region whose gravity is pulling thousands of galaxies toward it, including our own. We are not drifting randomly through space. We are flowing along a filament, being drawn by the currents of the cosmic web. But even Laniakea is not the final word. It is just a section of an even greater network, stretching far beyond what we can see. The universe does not give us clear boundaries. Superclusters blend into one another, filaments interconnect, and voids open like endless caverns. When we map these structures, we are not looking at isolated objects, but at the flow of matter on the grandest scales. It is like tracing the veins of a leaf and discovering they extend beyond the leaf, into the tree, and into the forest beyond. To understand how such immense patterns arise, physicists turn to mathematics. One useful concept is called percolation theory. Imagine pouring water onto a sponge. At first, the water seeps into isolated pockets, but as you add more, the pockets connect, and soon the water flows across the entire sponge. The cosmic web forms in a similar way. Tiny fluctuations in the early universe grew under gravity until they connected into a continuous network. Galaxies formed in the densest regions, tracing the outlines of these cosmic rivers. The web is the percolation of matter on the largest scale. Another concept is fractals. A fractal is a pattern that repeats at different scales. Coastlines, mountains, and snowflakes all display fractal qualities. The cosmic web, too, has a fractal-like nature. Zoom in, and you find clusters of galaxies. Zoom in further, and you find groups within clusters and galaxies within groups. Zoom in again, and you find stars within galaxies, planets around stars, and moons around planets. Each level reveals structure nested within structure, a hierarchy that continues downward. While the universe is not a perfect fractal, it is fractal-like, echoing patterns across scales. And then there are the voids, the great empty spaces that make the filaments stand out. Some voids are so vast they contain fewer galaxies than we can count on one hand. These are not mistakes or anomalies. They are essential features of the web. Without the voids, there would be no filaments. Just as rivers carve valleys, gravity carves filaments by emptying out the spaces between them. The voids are the silence that allows the cosmic symphony to be heard. When we compare this to the brain, the parallel grows richer. The brain is not just a mass of connections. It also has voids, spaces where neurons are absent, areas where silence allows for contrast. Information in the brain depends on both presence and absence, just as the cosmic web depends on both filaments and voids. Complexity requires balance, and that balance emerges in both neural and cosmic networks. It is tempting to wonder whether there is a deeper principle at work, some law of complexity that transcends scale. In the 20th century, scientists discovered that many complex systems share common mathematical properties. Whether it is the branching of rivers, the growth of cities, or the spread of the internet, certain network laws repeat. Perhaps the universe and the brain are both expressions of this universal mathematics. If so, then the resemblance is no accident. It is the echo of a fundamental truth. That order takes shape through connection. But let us not forget the differences. The brain is alive. It is the product of evolution, sculpted by natural selection to process information and ensure survival. The cosmic web is not alive in the same way. It is the product of physics, sculpted by gravity and dark matter. The brain creates thoughts. The cosmic web creates galaxies. To conflate them would be to mistake metaphor for reality. Yet, to compare them is to glimpse the unity of nature, that the same rules can give rise to life and to cosmos alike. As we push further into the future, our ability to map the cosmic web grows. New telescopes, such as the James Webb Space Telescope and upcoming surveys, will peer deeper into the early universe, mapping the filaments when they were just beginning to form. We will see the web in its infancy, a fragile lattice of gas and dark matter stretching across the cosmos. Already, simulations are revealing structures that match observations with extraordinary precision. The cosmic web is no longer just a theory. It is a measured reality, and yet it is also a fleeting one. Dark energy is accelerating the expansion of the universe. Over time, this will stretch the web until its filaments snap. Galaxies will recede beyond the cosmic horizon, disappearing from view forever. In the far future, observers in our galaxy will look up and see only the Milky Way and its immediate neighbors. The cosmic web will be gone, invisible, erased by expansion. Its memory will survive only in maps and in the fossil light we capture today. This brings us back to the brain. The brain, too, is temporary. Neurons fire, connections form, thoughts arise and then fade. Memory itself is fragile. Consciousness, like the cosmic web, is a transient pattern. And yet, in the brief moment it exists, it carries meaning. The universe has built a structure vast enough to give rise to galaxies, and within one of those galaxies, it has built a brain capable of recognizing the pattern. The web and the brain are mirrors of one another, not in function, but in form, reminding us that we are part of the same story. So, the next time you look at an image of the cosmic web, imagine neurons firing in a brain. Imagine ideas flowing, memories forming, consciousness sparking, and then remember that what you are imagining is the universe itself, reflected at a different scale. The brain is the cosmos thinking, and the cosmos is the brain unfolding. The web of galaxies and the web of neurons are not the same, but they rhyme, and in that rhyme lies a truth. Patterns repeat, and through those patterns we find our place in the grand design. The cosmic web is the largest structure we can see, the grand architecture of the universe revealed by gravity and dark matter. It spans billions of light years, yet its shape echoes in the smallest corners of nature. From the branching of trees to the networks of neurons in our brains, from the flow of rivers to the spread of lightning across the sky, the same principles emerge again and again. Nature writes in networks. The resemblance between the web of galaxies and the web of neurons is not proof that the universe is a brain, or that it thinks as we do. It is a reminder of something subtler and more profound, that the laws of physics are universal, that they give rise to patterns that span from the microscopic to the cosmic. These patterns do not need to be alive to inspire awe. They are the fingerprints of the same reality, scaled across 27 orders of magnitude. The brain allows us to perceive the cosmos. The cosmos allows brains to exist at all. They are different expressions of the same underlying order. When the two mirror one another, it is not coincidence. It is inevitability. It is what happens when matter organizes under the same rules, whether in a skull or across the universe. One day, the cosmic web will unravel. Expansion will carry galaxies away, and the filaments will stretch into darkness. One day, each brain will also dissolve, its networks fading into silence. But in this brief window, both exist. Both shine with the light of complexity. Both remind us that we are connected to the universe not only through matter, but through pattern. When we map the cosmic web, we are not just tracing galaxies. We are seeing the larger system that makes us possible. When we compare it to the brain, we glimpse the unity of nature, that the same equations can shape stars and thoughts alike. The cosmic web is not a brain, but the fact that we can even ask the question shows that the brain and the universe are part of the same story. And so, as we zoom out to the scale of the cosmos, and then zoom back into the scale of the mind, we find the same message written in both: connection, pattern, and order born from chaos. The neurons fire, the galaxies shine, and between them stretches the web of existence. To look at it is to see the universe as it truly is: vast, intricate, and strangely familiar. Perhaps the universe does not think, but through us, it dreams.